Okay, let's try this. So the lesson we're going to be talking about today is called Solving Basic One Variable Quadratic Equations. And let's talk about pretty much our goal. Okay, so one of the standards is this guy here. And it is to solve quadratic equations by inspection. And it's A1, A, REI, B3, part B. So specifically taking square roots, that kind of thing. You're not going to need to know how to complete the square in this part of the lesson. You might need to use factoring, but no quadratic formula or complex solutions, so don't even worry about any of that. You've got A1, AC, DA1, so you will be creating equations and inequalities in one variable and using them to solve problems. So that's a goal you're trying to meet in this lesson, and then the other standard is A1.A.SSE.A1, which is interpret expressions that represent a quantity in terms of its context. Interpret complicated expressions by viewing one or more of their parts as a single entity. So let's go back to this lesson. So here's our situation. A physics teacher put a ball at the top of a ramp and let it roll down toward the floor. Class determined that the height of the ball could be represented by the equation h equals -16t squared plus 4, where the height h is measured in feet from the ground and time t is measured in seconds. So right off the bat, you see that standard there. We're trying to interpret expressions that represent a quantity in terms of its context. So this equation talks about height. So it says, what do you notice about the structure of the quadratic expression in this problem? So I want you to try and pause the video and see if you can figure it out before we go over it. There is no C term, okay? So there's a few things that we can do with that. One of them you might have already thought about in your head, but we're going to go ahead and keep on trucking. So in the equation, it says explain what the 4 means. So let's talk about this. I'm going to try and do an example here. So h represents the height of the ball, right? So if h represents the height of the ball, and we've got this equation -16t squared plus 4, height is the height of the ball at any time, and then t is the time elapsed since we've let the ball go. So think about this for a second. If we plug in t equals 0, we're going to get that the height is equal to -16 times 0 squared plus 4, okay? So -16 times 0 is going to give us 0. And 0 plus 4 is just 4. So what this is telling me is it's the height at time 0. So when we release the ball at the top of that ramp, right? When we release the ball at the top of that ramp, what it's telling us is it's telling us that that ball is actually going to be 4 meters up in the air. So right here, I'm going to try and draw this over here. This nice little triangle. Happy little triangle. Happy little ball. Right, this ball, it's telling us that this ball is 4 meters in the air. Okay? I think it was 4 meters. It's either 4 meters or 4 feet, so please excuse that. It's feet. It says feet. My bad. Used to dealing with meters. Okay. So it says in the equation, when we talked about that, explain how you would use the equation to determine the time it takes the ball to reach the floor. Okay, so this one, explain how you would use the equation to determine the time it takes for the ball to reach the floor. Okay, so if the ball reaches the floor, there's a few ways we can tackle this. One is the way you're familiar with, okay? So first of all, we're saying how long does it take for that ball to reach the floor? So the first thing is we've got to decide in the context of our problem what that means about t and h. And specifically, they're asking for time. So time is going to be our unknown here. Time is the unknown in part C. And that's specifically we're trying to find, right, goal in this case. We want to know when the ball hits the floor. And so if I go up here and I look at this and I think about this ball rolling down, well, the floor is down here. So at this time, at t equals 0, the ball is 4 feet in the air. But at some time unknown that we're going to solve for using some algebra, this ball is somewhere down here on the floor. He's moved. I'm going to keep that color, keep it consistent. So when the ball is on the floor, the question is how far is the ball from the floor when it's on the floor? Well, if I measure this height, right, the height between the ball and the ground, height would be 0. So that's our indicator. That tells us what height is. So in this case, we're going to plug 0 in for height. Okay, so if the ball is on the floor, its height from the floor is definitely 0. So I've got 0 equals negative 16t squared plus 4. So I'm going to show you 2 methods to solve this out. The first method we're going to talk about you might be familiar with. Okay, so I've got a GCF here. My GCF is negative 4. And I'm going to make it negative 4 just to get rid of that negative there to make it nice. So negative 16 divided by negative 4 is going to give me 4t squared. And then 4 divided by 4 is going to give me 1. Now 4 and 1 are perfect squares, and that should be a negative there. So that's my bad. 4 divided by negative 4 is negative 1. So I've got 2 squares here, right? 4 is a square, t squared, and then I've got 1 here. So what I can do is I can use a formula that we're familiar with, which is the difference of squares. So I've got negative 4, 2t plus 1, and 2t minus 1. So if you got kind of confused here, just review some of those other lessons where we factored things that were a difference of squares. So that's one method. So right here, I can already start to solve some of this out. I can take 2t plus 1 and set it equal to 0. Or I can take 2t minus 1 and set it equal to 0. So if I subtract 1 from both sides of this equation, I get 2t equals negative 1, and then t equals negative 1/2. Over here, if I add 1, I get 2t equals 1, and t equals 1/2. And this is the first time where you're going to encounter something in math known as extraneous solutions. And extraneous solutions don't make sense in the context of our problem. So if we're talking about time, something that we consider whenever we're dealing with any equation like this is that time is greater than or equal to 0, right? Time moves forward. Whenever you start a stopwatch, it starts at 0. You're never going to see a stopwatch go backward, right? It's never going to say negative 1/2. If it does, for some odd reason, go backward, then you've either, invented some sort of weird time machine, right? So here's the time machine. Let's make it, yeah, that's fun. So there's the clock. I don't know, there's the blue frilly electrical. So you've either invented a time machine and it's lighting up and it's taking you back in time, or we call that stopwatch broken, okay? So in this case, our extraneous solution is negative 1/2, okay? In this case, 1/2 makes sense. So it's saying that, okay, after 1/2 of a second, if I used a stopwatch, or if I used a cell phone, which they do that now, they record the time it takes. If I record the time it takes for this ball to be released to the bottom, it's going to take 1/2 of a second, okay? So let's go back to this. It says, now consider the 2 solutions for t. Which one's reasonable? Does the final answer make sense based on this context? So we talked about that. So that's the extraneous solution that we talked about down here. Time cannot be negative. So time, something to note here, is time is non-negative, okay? In other words, t is greater than or equal to 0, okay? Thou shalt not go back in time. If you do, I haven't seen it. You might be rich. Hey, here's our next example. I'll make sure you guys can see it. Lord Brian is designing a set of square garden plots. so some peasant families in his kingdom can grow vegetables. The minimum size for a plot recommended for vegetable gardening is at least 2 meters on each side. Lord Brian has enough space around the castle to make bigger lots. He decides that each lot should be the minimum 2 meters plus an additional X meters. So Lord Brian, so let's try and kind of dissect this. So he's designing a set of square garden plots so some families in his kingdom can grow vegetables. Okay, so the minimum size for a plot recommends for a vegetable gardening is at least 2 meters on each side. Okay, so we can do that. So let's go over here. So at least 2 meters on each side. Lord Brian has enough space around the castle to make bigger lots. So he decides that each side should be the minimum 2 meters plus an additional X meter. And it says, what expression can represent the area of one individual garden based on the undecided additional length X? So pause the video, and then we're going to go over it. Okay, so what we've got here is a minimum of 2 units here. And then there's some unspecified amount that this king has said he wants his peasants to add to their farms. Okay, so this unspecified amount we're going to call X. Okay, so this distance here is X. So whatever X length is. And then down here, this distance is also X. So essentially what we're doing here is with these 2 by 2 squares, we're extending them by X units, okay? And so what we're doing is we're creating the area model that we've kind of seen in some other examples. So if I kind of work all this out, right? I know the area of the initial piece, the minimum length is going to be 4. So that length is 4. And then I start to calculate these other area bits. So I take X and I multiply it by 2. Okay, so I get 2X here. And then I take 2 and then I multiply it by X. I get another 2X. And then I've got X times X. So that's going to be X squared. So if I add up all this area, all in all, I've got X plus 2 squared, which anytime you square a binomial like this, be careful, don't distribute the 2. You can take X plus 2 and write it twice, and then multiply all this out, and you're going to get exactly what we got over here. So you're going to get X squared plus 2X plus 2X plus 4, and you get X squared plus 4X plus 4. So that's one way of thinking about it. Okay, so essentially X plus 2 quantity squared. So it says there are 12 families in the kingdom. So let's go back over there. So there are 12 families in the kingdom who are interested in growing vegetables in the gardens. What equation can represent the total area of the 12 gardens? Okay, well, if one area of the garden is X plus 2 squared, which is equal to X squared plus 4X plus 4. And how much would 12 times that area be? Well, all I have to do is take 12A, right? So I'm going to call this area total. So area total is equal to 12 times this guy, which is the same as 12 times this guy, which is the same as 12 times this guy. So I'm just going to write 12 X plus 2 quantity squared. Okay. So it says, if the total area available for the gardens is 300 square meters for the entire thing, what are the dimensions of each garden? Okay, so if we're talking about each person, each of these peasants, right, it tells us that the total area is going to equal 300. So what we can do is we can start to solve some of this out. So you've got 300 equals 12 and X plus 2 quantity squared. So if you take a look at this, you might be a little baffled, but this is the first time we've encountered something like this. All you have to do is we have to isolate this parentheses and get the square term alone so we can undo it, okay? So what we're going to do is divide both sides by 12. That's going to give us 25. So we get x plus 2, quantity squared, equals 25. And then what we do is we take the square root. And whenever we take the square root of a number in an equation like this, on the right-hand side, we write plus and minus. And the reason is because the square root of x squared is actually equal to absolute value of x. So this will actually have two solutions in here, both are positive and a negative, okay? So we can't decide whether it was positive or negative before, but we will be able to here in a second because of extraneous solutions, okay? So if I take the square root and I undo this square, I've got plus and minus down here 5, and I've got x plus 2. So this gives me two solutions. So x plus 2 or equals positive 5, or x plus 2 equals negative 5. So if I subtract 2 from this side, I get x is equal to 3, which in this case I think means feet or means meters. So let's check. Always have to check. It's meters. Okay, so up here it says meters. So over here, I should probably fix that. Right, whatever unit they give you, that's the unit you're working in. So that's 3 meters. And over here, if I subtract 2, I get x equals negative 7. Well, I can't have negative 7 side length of an area. I mean, of a rectangle, right? If I put negative 7 into this problem, the area would come out to be positive 25, but I've got negative side lengths. It's like owing somebody a side length of garden. So that does not work. It's called an extraneous solution like we mentioned earlier. Okay? So this does not make sense in our problem. So we call it extraneous solution. So I had a conversation with some of my students about this one time, and they actually call extraneous solutions garbage solutions, right? Because we looked up what extraneous meant, and it meant that they can be discarded. So whenever they said discarded, they automatically thought garbage, okay? So we throw those in the trash can. If they don't make sense in our problem and we solved it correctly, we get a correct answer and an incorrect answer, we ignore the incorrect answer, we yeet it into the garbage, okay? And then over here, we've got x equals 3 meters. Well, x equals 3, so that works up here. So if I go up here, check my work, if I plug this in, I get 3 here and 3 here, and we're saying each garden is going to be 25 square feet. So if I plug in 3 feet here, I get 3 plus 2 squared, which is 5 squared, which is equal to 25. Now, let's take a look at the rest of this. And we got some equations here. So there's a few ways you could solve these equations, but we're going to go with the easy inspection method, okay? So 3x squared minus 9 equals 0. Well, all I'm going to do is I take exactly that equation, set it equal to 0, and then I start to solve for x like normal, okay? There's no linear term, so when there's no linear term, I can do this. Otherwise, try and factor. So no linear term. I get 3x squared equals 9 if I add 9 to both sides. So let me write that up over here. It's better. So 3x squared minus 9 equals 0. Add 9, right? If I add 9, I get 3x squared equals 9. I get x squared equals 3. And then I get x equals plus or minus, right here I'm taking a square root, so if I take a square root of both sides, I get x is equal to plus or minus root 3, okay? So in this case, I get a positive and a negative, but what it's telling me is kind of like what we were talking about earlier, those two solutions where our quadratic is going to hit the x-axis, okay? It's not mentioning something in a context, so you might be wondering, okay, we need to get rid of the negative, because time doesn't matter, but here, this is just an exercise. There's actually no context to go along with it. So both solutions are valid. Okay? So over here, we're done. So remember, don't forget that other standard. What was it? A2, APR. Starting to go off the page here. A.2, which was, okay, if I've got a quadratic, I can construct its rough graph if I have the A term and I have the solution. So the A term is positive, so that tells me it points upward. And then I have those two solutions, so it looks something like this. So let's do another one. So let's go back to this lesson. Here's our next exercise. So exercise 2. So exercise 2 is telling us to solve x minus 3 squared equals 1. And then x minus 3 equals 1. Plus and minus 1, right? We took a square root. So anytime you take a square root of this, it creates this equation. So it tells me the absolute value of x minus 3 equals 1, which then means, make sure I write this neater. Okay, I'm just going to write it like that. And then hope that this works. Which is if and only if x minus 3 equals plus or minus 1. Plus or minus 1. So then x equals 3 plus or minus 1, which means x is both 3 minus 1, which is 2, and then 3 plus 1, which is 4. So that's telling me that this quadratic, this x minus 3 x minus 3 squared equals 1. If I looked at these x values, they would hit here and here, okay? Okay, let's talk about exercise 3. So it's the exact same, almost the exact same as the first one we dealt with. So 4 times quantity x minus 3 squared equals 1. So we're going to work that one out. So again, I encourage you to pause the video, see if you can work it out on your own. We're going to get through it. So the first thing I want to do, assuming you've worked it out, is divide that 4 over, right? 4 is being multiplied, so I want to undo it. So I've got x minus 3 squared equals 1 over 4. So then I want to take the square root of both sides. Whenever you take a square root, make sure that you write a plus or minus over here. This is plus or minus the square root of 1/4. Whenever I square root a fraction, okay, so an aside, talk about what's the square root of 1 over 4 is. The square root of a fraction is going to be equal to the square root of the top of that fraction divided by the square root of the bottom of that fraction, okay? So keep that in mind. So if I take the square root of 1 and the square root of 4, I'm left with plus or minus 1/2, okay? And over here, I'm left with x minus 3. So if I add 3 to both sides, I get 3 plus or minus 1/2. So 3 plus 1/2, if I think about this in terms of 3 is 6 over 2, I get 2 solutions. So 6 minus 1 is 5 over 2, and then 6 plus 1 is 7 over 2. So those are my 2 solutions there. And let's do a hard one. Not really hard. I mean, I don't think they're that hard. This one's just going to involve a square root, so it's going to look a little more complicated, but that's okay. We can do complicated. So that was 2 x minus 3 squared equals 12. And we're going to solve this the exact same way. So I've got x minus 3 squared equals 6. So I divide it here. So divide by 2. Divide by 2. And then I'm going to take the square root. All right, so I get x minus 3 equals plus or minus square root 6, okay? So if you cannot take the square root, of the number, just leave it inside. You don't have to whip out your calculator to look at what this number is. It's algebraically correct to just leave it as root 6. If it doesn't have a square root, just leave it inside. If it does, take the square root by all means. If you don't know if it has a square root, right, you can look over your multiplication tables, you can look at your calculator. If you get a decimal when you take the root, it's probably not a perfect square unless you typed it in wrong, okay? So just leave it as root 6 and just understand that it's plus or minus whatever the decimal form of root 6 is, okay? It's just a number. So, right, we took the square root. Took the square root. So that was the step. And the next thing we're going to do is add 3 to both sides. So if I add 3 to both sides, I get x is both equal to minus 3 minus root 6, and then 3 plus root 6. So if I'm going to write this solution set out down here, I get 3 minus root 6 and 3 plus root 6. So if I type that into a calculator, I do get a number, okay? But whenever you're working out this algebra, you're going to leave it that as it is. Okay, so then it says, analyze the solutions for exercises 2 through 4. Notice how the equations had x minus 3 squared as a factor, but each solution was different. Radical, mixed number, whole number. Explain how the structure of each expression affected each problem solution pair. Take a second to think about that. So right here, the differences between these few examples is for this one, whenever I take the square root of both sides, one is a perfect square, so it's easy to work with, right? On the right-hand side, I'm getting plus or minus 1. For the second equation, I'm still getting somewhat of a nice solution. It's not an irrational number yet, but I am getting fractions. But these fractions are set up in this equation so that whenever I take a square root, I can take the square root of the top and the square root of the bottom. So that's something to think about. So whenever I solve this out, I get some rational numbers, which are, right, they're a ratio of two numbers. So integers are rational numbers, but rational numbers, not all rational numbers are integers, okay? So that just means fractions. And then down here, right, I divide both sides by 2, take the square root, but I cannot take the square root of this guy. So this guy is an irrational number. Irrational number. So irrational number. And all an irrational number is it's numbers that never terminate or never repeat. So in this case, root 2 would be 1, root 3 is 1. And then we just found root 6 is 1. Root 7 is probably 1. Anything you can't take the square root of, but you try to, not evenly, right, without a calculator. You use a calculator, you'll get exact, not exact, but really close approximations. And then numbers like pi, right? Pi is a number, right? We approximate it to be 3.14, not 3:14 o'clock. So just ignore that. Rid of that. 3.14, and another one is e. So you might not have seen e, but it's a number like pi, and probably just as important as pi, but it's approximated to be 2.71. Okay, so these are irrational numbers. So that's what it was talking about right here. Okay, so Peter is a painter and he wonders if he would have time to catch a paint bucket drop from his ladder before it hits the ground. He drops a bucket from his 9-foot ladder. The height h of the bucket during its fall can be represented by the equation -16t squared plus 9, where the height is measured in feet from the ground and the time since the bucket was dropped, t is measured in seconds. How many seconds does the bucket hit the ground? Do you think you could catch the bucket before it hits the ground? Well, -16t squared plus 9, we're going to find out when that hits the ground. And so we can do this one of two ways. We can factor like we did earlier. We can factor out a negative, and then we can solve it out that way. But we're actually going to solve it a different way. So all I'm going to do here is subtract 9 from both sides of the equation. So I get negative 16t squared equals negative 9. And then I can divide both sides by negative 16. And this amazing thing happens when I divide by negative 16. I get 9 over 16. And right, I can take the square root of both sides. I have to remember my plus and minus on the right-hand side whenever I take a square root. So square root that side and square root that side. But I get t equals plus or minus, well, the square root of 9 over the square root of 16 is going to be equal to this, just 3 over 4. And so, right, t equals negative 3/4 and positive 3/4. So 3/4 is about 0.75. And so in the context of this problem, I don't need negative 3/4 because remember this problem is in a context. It's called extraneous. Right here it says, right, I'm dealing with height and time. So h is measured in feet and time is measured in, what was it, seconds? Yeah, time is measured in seconds. So I don't want time to be negative here. So that's the context they were talking about. I don't need time to be negative. So right here, if I take a look at this guy, positive 3/4 is my only answer. So 3/4, if you forgot your fractions, is about 0.75 of a second. So unless he jumps and catches that paint bucket before he reaches the ground, there's probably no way he's going to be able to let it go and then get it on the ground before he gets down from the ladder. And if you think about that, that makes sense, right? If I'm up on the side of a house, if I have a paint bucket and I try and drop it, I'm not going to be able to reach it in time, okay? So let's talk about this lesson summary. By looking at the structure of a quadratic equation, missing linear terms, perfect squares, factored expressions, you can find clues for the best method to solve it. Some strategies include setting the equation equal to 0, factoring out the GCF or common factors, and using the zero product property. So zero product property just means, right, whenever I have something like, you've done the zero product property, you just did notes called the zero product property. Whenever I have x plus 2 and then 2x plus 5 equals 0, I'm going to take each factor and set it equal to 0 and solve it out. So this first one I can subtract 2, and then 2x equals negative 5, and then x equals negative 5 over 2. So you're telling yourself, okay, either this is 0 or this is 0, okay, or both are 0 in order for this equation to be true. So what makes x plus 2 0? Well, if I plug in negative 2 there, I'm going to get negative 2 plus 2, which is 0, okay? So if I plug this guy in here, that'll be 0. And if I plug negative 5 over 2 over here in for this expression, 2 divided by 2 is 1. Negative 5 plus 5 is 0. So that works. So that's zero product property. So, and then be aware of the domain and range for a function represented in context and consider whether answers may make sense in that context. And that's just kind of recapping on some of these other things like down here, right? This paint bucket, time is non-negative, okay? And if you think about it, height is probably non-negative too. Because if I go negative, I'm in the ground, okay? And then up here, same thing, right? I can't have a negative side length. So that you were thinking about the domain here, right? I can't plug in negative numbers in for length or area. And then up here, right, same thing with time. Time can't be negative, and then probably height can't be negative unless there's a hole here. If there's a hole here, you're fine. If there's not a hole there, you're not fine.